Good evening. Welcome to the another session of mathematics. In this session, we'll start from question number 66. Let's go to that. So we are given a convex pentagon. So convex pentagon is taken like this. So yeah, it's a convex pentagon. So the meaning of giving convex pentagon is that you shouldn't be taking this way, which is also pentagon, but this is not convex. This one is convex pentagon. So all these angles are theta 1 and then theta 2. And then similarly, we have here theta 5. So we are given a relation that theta 1 is less than theta 2. And when I plug in theta 2, I get theta 3 here. Then theta 4 and less than theta 5. That's what we have. And now we need to find out all these steps. So first of all, we know the sum of interior angles of the polygon. So sum of the interior angles of the regular polygon. Even if it is not, we don't care because ultimately we want the sum of the interior angles of polygon. So it is simply n minus 2 pi. And n is the number of sides here. How many are given? So here it's pentagon, so n will be 5. So therefore, here in this case, we have all the theta i's, the sum up to 5 minus 2, which is 3 pi. So for n is equal to 5, we get the sum is 3 pi. That means I have theta 1 plus theta 2 plus theta 3 plus theta 4 plus theta 5 will be equal to 3 pi. Now we want cos of theta 1 plus theta 2. That means this quantity, I can keep it here. And the remaining thing I can transfer to that side. So I'll be having 3 pi minus of theta 1 plus theta 2. We can take cos on both sides. So I'll be having cos theta 3 plus theta 4 plus theta 5 will be equal to cos of 3 pi minus same stuff, theta 1 plus theta 2. So cos of 3 pi minus something will be minus cos. So it will be theta 1 plus theta 2. And then here we have cos of theta 3 plus theta 4 plus theta 5. So we can now divide it here. So I get this value to be minus 1. So that means the first part we had broken, and that turns out to be minus 1. Now, if you watch it carefully, then we have theta 1, theta 2, theta 3. So in the next case, we can keep this one here and transfer remaining to that side. And this again gives me the same strength, and that also gives me minus 1. So I get lambda is equal to 2 eventually. So my lambda is equal to 2, and that is confirmed. So once my lambda becomes 2, now the next part is to go with this f of n. So f of n now we can find out. So f of n would be the product starts from k equal to 1 to n. Okay, so k is equal to 1 to n. It's 1 minus tan square of, and now we have 2 to the power k pi. So that is 2 to the power k pi over 2 to the power n plus, that's what we have. Yes, let's go ahead. So this is a product, that's telescoping product actually. So now we have the product, and we want to find out the value of this thing as a function. So we want f of n clearly. So in that case, we'll go for finding the product for this thing. So we know here, we'll think about tan 2 theta. So tan 2 theta, if you watch carefully, then it is 2 tan theta over 1 minus tan square theta. So which means I can simplify this thing to be product k is equal to 1 to n. And 1 minus tan square I can write down 2 tan theta. Theta is this quantity, by the way. So which is 2 power k pi over 2 power n plus 1, and then upon tan 2 theta. Tan 2 theta will become 2 power k plus 1 here. I'll be having this over 2 to the power n plus 1. So we have found that product part for this, and now this 2 can be taken outside n times. And now for this thing, we'll simply apply the product. So I get tan 2 pi over 2 to the power n plus 1. This over tan of, here this quantity is going to give me 2 square pi over 2 to the power n plus 1. And when I write the next term, then this becomes tan of 2 square pi over 2 power n plus 1. And the same stuff I'll be writing here. So tan of 2 power 3 pi over 2 power n plus 1. And this would go on up to tan 2 to the power n pi over 2 power n plus 1 over tan of 2 to the power n plus 1 pi over 2 power n plus 1. And now you see here, most of them gets cancelled. So except for the first one and then this one. So this one I can further simplify to 2 to the power n into this quantity. I can write down tan of, this will be 2 pi over 2 power n plus 1. And here if you look at the denominator, then here we have 2 power n plus 1 pi. So 2 power n plus 1 pi, we can write down like this, tan of 2 pi minus 2 pi over 2 power n plus 1. So ultimately, when we multiply here, we get the same stuff. Why? Because we have 2 power n plus 1 into pi minus 2 pi, and then plus 2 pi minus 2 pi. So this eventually gets cancelled, and we get the same stuff. So now here we know this is theta, and then we have tan 2 pi minus theta, so which is minus tan theta. So this part gets cancelled, leaving us with minus 2 to the power n. So that means my f of n is minus 2 to the power n. Now let us visit this options. So we have here f of n is equal to minus 2 to the power n, and lambda is equal to 2. So we'll start attacking the options one by one. So first we'll go ahead with the remainder when f of 2026 is divided by 9. So f of 2026 modulus will give me basically 2 to the power 2026, and we are dividing by 9. So that means we could write here 2 cube here, and then this is 2026, right? So 2026 we can write in the form of 2. So we can write here 2000. Then this is right. Oh, sorry. So if you're using the remainder theorem, we have to write down powers of 2 in the form of something which is very close to 9, so that we can use the remainder theorem or the binomial, your choice. So ultimate goal would be right now here 2025 and then into 2, because this guy is divisible now by 3. Yes. So now this one I can write down 2 to the power 3, and then from 3, if I divide this thing, so 3 6 are 18, and 3 7s are 21, 3 5s are 15, and then. So now this part, 2 cube, I can further write down as 8. 8 is 9 minus 1. So it is 9 minus 1 to the power 675 into 2. So now this is divisible by 9, so I'll be left with only minus 1 to the power 675 at the end, which is minus 1. Then I'll multiply 2, so I get here minus 2. So, but I want the remainder to be positive, so minus 2, I can write down minus 2 plus 9 minus 9. So this part is divisible by 9. That means remainder must be 7. So yes, option A is correct. And now if you see, then mod of f of 1, 2, 3, 4, 5, 6, 7, 8, 9 has positive integral divisors greater than this. So if you watch this carefully, then I have here f of n. If you see, then we have 2 to the power 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is, of course, more than this. Okay, or its divisors are going to be 2 to the power many, so which are more than this number. So that means yes, option B is also true, because they are saying that it has positive integral divisors which are greater than 1, 2, 3, 4, 5, 6, 7, 8, 9. So this option we could say directly by common sense that yes, it's correct. Now let's go for option C. So option C is asking us to find out this root lambda, 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 and so on to how many times? 1, 2, 3, 4, 5, 6 times. So let's go ahead. So if I have to find out here, square root of this is 2 plus square root of 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 2. That's what we know. 2, 3, 4, 5, 6. No one more. Plus square root of 10. So if we see this carefully, then I can take this one as x1. So I have say x1 is equal to square root of 2. So if I look at the second one, then x2 is basically square root of 2 plus x1 I have. And then we have x3 is equal to square root of 2 plus square root of x2. Is ultimately the same thing. So we could write 2 plus square root of this. Yeah. So this will go on eventually. So that means now I want to find out this sum. So can I take this quantity as 2 times cos pi by 4? So I could write x1 is equal to root 2, which is nothing but 2 times cos pi by 4. So if I plug in this one here, so I'll be having x2 is equal to square root of 2 plus 2 times cos pi by 4. So this would give me 2 common, and then 1 plus cos is 2 cos square pi by 8. So which is 2 times cos pi by 8. So x2 is going to be 2 times cos pi by 8. So similarly, we're going to get x3, and this is going to be 2 times cos pi by 16. So now we understood that xn is going to be basically 2 times cos of pi by 2 to the power n plus 1. And that's the pattern we noticed. For 1, we are getting 2 here, and for 2, we are getting 2 to the power 3. For 3, we're getting 2 power 4. That means if I generalize for x, and I'll be having 2 cos pi over 2 to the power n. So here we have this thing. That means we need to count how many 2's I have written. So 1, 2, 3, 4, 5, 6. So for x6, I'll be having 2 times cos of pi by 2 to the power 7. So is this correct here? 2 cos pi by 2 to the power 7. So yes, that is also correct. And then now only value of lambda which satisfies lambda power lambda is same as 2 lambda is same as lambda square is lambda. So here it is quite simple and obvious to see here. If I say lambda power lambda is equal to just lambda square, then from here I get lambda is equal to 2. And the value of lambda we have got is 2. So of course, that's the only number is for which we have 2 plus 2 is equal to 2 into 2, which is same as 2 to the power 2. So yeah, D is also correct. So I hope this makes sense. Let's go for the next question, number 67. So look at question number 67. Now here we have given a polynomial f of x is equal to x to the power 5 plus x squared plus 1. And f of x has roots alpha I equal to 1, 2, 3, 4, 5. And g of x is a monic quadratic polynomial, so that roots of g of x is equal to 0 are irrational and of opposite sign and equal in magnitude, and their product is 2. So it's like this. Their product is basically 2, and x1 plus x2 is equal to 0. They're irrational and opposite signs. So of course, that means we can take x1 is equal to root 2 and x2 is equal to minus 2 root 2. That product. Oh, it's not 2, it's actually minus 2. So that means now I'll be having g of x is equal to x square minus 2. So now suppose f of x is equal to 0. Let's say I have x power 5 plus x square plus 1 equal to 0. And here we have got 5 roots. Say alpha 1, alpha 2, alpha 3, alpha 4, alpha 5. Now, these values of, I want here g of xi product. That means g of x1. That means these are roots here. These are alpha i's, or say xi is here. So all these roots I want basically. G of x, I is equal to 1 to 1. So G of this is alpha, not alpha. It's DTP typing error. It's G of alpha I, and this is also this product of x i's. Yeah, fine. Now this will give me I equal to 1 to 5 G of alpha I minus 12 times G of product of this alpha I. So okay. So at least the product we know. So product of alpha I, if we see here, then it is x to the power 5 plus x square. So we could write product as plus 1. So this is 1. Then plus 5 minus 5, this is fine. And then now we need the g of alpha I. That means we want all these values here, g of alpha I, and we want to plug in everything here. So instead of finding this part, g of alpha I, we can g of alpha I. So alpha I is going to be what? Alpha I square minus 2. So alpha I do not know what it is, but alpha I know it satisfies this. That is alpha I power 5 plus alpha I square plus 1 is equal to 0. So that means if by some method, if I can construct a polynomial, whose roots are, so goal is to get a polynomial. So goal is to get a polynomial whose roots are g of alpha I is basically, so that we can find out their product. So this is the product of the roots. This is root of the product here. So we directly get this value. So product of alpha is 1. So g of 1 is going to be 1 minus 2, which is minus 2. So g of 1 we have at least, and that is minus 2 from here. No, 1 minus 2, which is minus 1. Yeah. So g of 1 we have got. That means now we need to get this. So for this thing, what we will do, we'll take alpha I square minus 2 is equal to some t. So my alpha I square will be t plus 2. So that means alpha I is going to be plus or minus square root of t plus 2. Now let's alpha I satisfying this polynomial, so we can plug in here. So in that case, I'll be having plus or minus square root of t plus 2 to the power 5 plus plus or minus square root of t plus 2 to the power 2 plus 1 equal to 0. So we need to get the polynomial in t, and all I need is just the product, because the ultimate goal is done. Because this entire thing is t, and this entire thing is nothing but g of alpha I. So t is nothing but g of alpha I if you see carefully. So we want the product. That means we want the product of t's. That means I just need a polynomial here. That's it. So here we can simplify this by writing here t plus 2 to the power 5 is equal to, here this part is gone, so we get minus t minus 4 t 2. It's just t plus 2 plus 1. So yeah, minus 3. And now we'll simply again square this. So when I square this plus minus along with the square root gets disappeared, and I get t plus 2 to the power 5 is equal to t square plus 6t plus 9 here. So that means if I open this polynomial, t plus 2 to the power 5, I just need the constant to come here. So this everything will open with plus. So that means it will open with t power 5 plus 5c1 into blah, 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 plus last term is going to be 2 to the power 5, and it's equal to this again t square plus 6t plus 9. I'm interested more into the constant. So 2 to the power 5 minus 9 is my constant, is equal to 0. This is my constant. So expression, I'm going to get something like this. So this is my constant, and which is nothing but the product of roots, and that is in plus. So 32 minus 9 is going to give me 23. So we'll just plug in here. So that gives me 23 minus 12 into minus 1. So 23 plus 12. So this will give me 45. So 23 plus 12, yes, so 35. So the answer would be here, 35. So moving to the next problem. Look at this. So we have circles with centers O1, O2, O3, and having the radii 1, 1 by 2, 1 by 4 respectively touch each other externally. So first, we'll break this much. So we have 3 circles. Just like this, basically. I don't know what to put around here. Okay. This is an extent. Okay. This is Let's give the clear message. So I have this circle whose center is here, O1. So this is my O1, and this one is going to be O2, and this one is going to be my O3. So the first circle has radii 1, so this is 1, and then O2 is half, and then third one is 1 by 4. And now for I more than 3, the circle with center OI defined as the circle touching OI minus 1. That means if I take the next circle, which is O4, then O4 should be touching OI is 4 basically. So it should be touching O3, and it should be touching O2. So that circle could be inside this or here basically, but they have given that it's farthest from O1. So that means I have to draw it here. So the new circle which is going to come now, okay, should be here. That's my new circle here. This is going to be my O4. And then this story would continue, O4, O5. So if I take here 5, then O5 will touch here. Let's take I is equal to 5. So it will touch O4 and O3. So O4 and O3, that means it is next circle in the row is going to come here. And it is of even smaller radius. So radii is going to be smaller every time. So now let's see what this problem is asking us. So I hope till here everything is fine. Now, if you look at this, then they have given the radius also. That's if I see here O4, then what is the radius of O4? It's 2 to the power 1 minus 3, which 1 minus 4, which is minus 3. So 2 power minus 3, which is 1 by 8. So that means now I have the AI denote the area of triangle with vertices O1, O2, O3. So if I take I equal to 1, so O1, O2, O3, and next is 2, 3, 4, 3, 4, 5, and so on. So that means all we want is this triangle basically. So we're interested into this triangle now. So this one is my O1, O2, O3 triangle. And the next one is going to be my O2, O3, O4 triangle here. And then next O3, O4, O5 here. And then this would go on eventually. So now what do we want is we want the sum of all these areas. So let's see how are we going to approach this. So first I'll construct the triangle itself. So this is my O1, O2, and then here I have O3. I'll construct one more also. And that is my O2, O3, and O4. O3 and O4. So now let's see. From this radius is 1. This radius is half. That means O1, O2 length is 1 plus half. And then O1, O3 is going to be 1 plus 1 by 4. So this is 1/4. And then O2, O3 is going to be half plus 1 by 4. So half plus 1 by 4. So now we'll go for O2, O4. So O2, O4 will become half plus 1 by 8. So half plus 1 by 8. Now if you see O3, O4, then O3, O4 will become, this is 1 by 4 and this is 1 by 8. So 1 by 4 plus 1 by 8. And if I see O2, O3, then O2, O3 we have written that is half plus 1 by 4. So if we see this triangle here, so if I take half common from each of them, so that means I'll be having, so take half common, so I get here 1 plus 1 by 2. If I take half common here, so I'm getting 1 plus 1 by 4. And if I take half common, then I'm getting 1 by 2 plus 1 by 4. Yes. So now if you notice, then 1 plus 1 by 2 is here also, 1 plus 1 by 4 is here also, 1 plus 1 by 2 is 1 by 2 plus 1 by 4 is here also. That means this triangle, all the sides I have just reduced it by half. So that means these two triangles must be similar. So that means, so if these two triangles are similar, so triangle O1, O2, O3 is going to be similar to triangle O2, O3, O4. And then this story would continue again because all the sides are getting reduced. So now I want to find out the areas basically interested in. So let's go for the areas. For areas, I'll be writing area of triangle O1, O2, O3 over area of triangle O2, O3, O4. So this will be equal to O1, O2 square by O2, O3 square. Theorem on areas of equal ratio. Theorem on areas. Yeah, so theorem on equal ratio. That theorem, which we were proud of in class 10th. Sure. Now, if you see here carefully, then we have O1, O2. So what is O1, O2? We need to find out. It's given here. O1, O2 is 1 plus half. So let's plug in there. So this gives me 1 plus 1 by 2 square. And then here we have O2, O3. So O2, O3 would become half plus 1 by 4. So which we can add on fondly by this half into let's say O2, O3. O1, O2 will be O1, O2 or O2, O3. So yeah, O2, O3 is here. O2, O3 is half plus 1 by 4. So yeah. So that is half plus 1 by 4 square. So this could be written as 1 plus 1 by 2 square, and here I can take half common. So this will become 1 plus 1 by 2 again, the whole square. So this two gets cancelled, I get here 4. So that means now I know that the area of triangle O1, O2, O3 is actually 4 times area of triangle O2, O3, O4. So that means this is the bigger triangle, and this is the little one. So if we want to get the relation in the little one, so we transfer 4 to that side. So I get area of triangle O2, O3, O4 is equal to 1/4 of area of triangle O1, O2, O3. So that means similarly now I can get others. So area of triangle O3, O4, O5 will now be 1/4 of O2, O3 area of triangle O2, O3, O4. This is 1 over 4 square of area of triangle O1, O2, O3. It's ultimately this. So now we get the series here. So we want A1 plus A2 plus A3 and so on. So this will be 1/4 of, we can take this area of triangle O1, O2, O3, O3 common. That's appearing everywhere. We need to add them up. So O1, O2, O3 here also, O1, O2, O3 here also. So we'll take area of triangle O1, O2, O3 common. Then I'll be left with 1 over 4 plus 1 over 4 square plus 1 over 4 cube, 1 over 4 to the power 4, and so on. So now ultimate goal is to find out this area of this triangle. So O1, O2, O3. Let's see what do we get. So we're given all the three sides for O1, O2, O3. Let's calculate the area. So this is O1, O2, O3 is going to be 1 plus 1 by 2 is 3 by 2 here, and 4 plus 5 by 4 here, and half plus 1 by 4 is 3 by 4 here. So these are my sides. Now I need to find out the area here. So first let's find the semi-perimeter. So area is going to be semi-perimeter into S minus A into S minus B into S minus C. So let us find out this thing and see what do we get. So semi-perimeter we can get directly. This is 4 here given. So 6 plus 5, 11 plus 3, 2 plus 6, 15. Need to add them up. So this is 3 by, no, 6 by 4 plus 5 by 4 plus 3 by 4, yeah. 14 by 4. But then we have to take its half. So I'll be having 7 by 4 actually. So half of this semi-perimeter is going to be 7 by 4 actually. So 7 by 4 is my perimeter. So let's plug in everything there. So done. So A1 is going to be square root of, it's 7 over 4 into, from 7 minus 4, 7 by 4, I'll be subtracting 5 by 4. So this gives me 2 over 4. And from 7, I'll be subtracting 3 minus 4. So 7 by 4 minus 0 is going to give me 1. And from 7 by 4, I'll subtract 6 by 4. So it gives me 1 by 4. So now here, everything gets 14 and 4 will be going 4 times. Okay. So we can add on here square root of 14 over 4 times 2. So this 4 will be out here, and then square root of 4 is 2. So we got this much. And now let's go for, so this could be written properly, to 14 over 8. And now if I see the sum of this series here, so we can write down here the root of 14 by 8. It's the sum, and then this area now. So this is going to be 1 over 4 over 1 minus 1 over 4. So this gives me a root 14 over 8 into 1 over 4, and then here we have 3 over 4. So this 4 and 4 gets cancelled. So I get 1 by 3. So this gives me root 14 over 24. It doesn't match with any of the options. Okay, so yeah, the mistake is here actually. We have written area of triangle O1, O2, O3. That also need to be added. So it should be 1 here first. So this makes it just 1. So now the actual thing is going to be root 14 over 8 into, this is going to be 4 by 3. So this gives me a root 14 over 6. I think that matches with option C. Please ignore these two word blue lines. Now, let's go for the next problem. Number 69. And here we have ABC lies on a plane in the first octant. So lying in the first octant, which means A, B, C must be positive. And this is what I wanted to say. Then now next part would be which is equally inclined to the 3 coordinates axis. Equally inclined to the 3 coordinate axis. and passes through a point. Okay, so that means if I write on the plane equation, so it will be simply looking like this: say x plus y plus z is equal to some d, because they are equally inclined to the three coordinate axis. That means the ds of the normal is going to be in the ratio 1:1:1. So I just need to find out d now. So for this d, it's given that distance from the origin is d by root 3, is 1 by root 3. So mod of d over root 3 is equal to 1 over root 3. So that means my d is going to be 1. I cannot have here -1 because that's not correct. So it would give me x plus y plus z is equal to 1. So that means my ABC lies on this plane. So ABC are lying on this plane. So which means I have a plus b plus c is equal to 1. So now I want the minimum value of this thing. So to get the minimum value of this thing, you can try through other inequalities if possible. Okay? And if not, you can try T2's lemma. So if I apply T2's lemma here, so what is T2's lemma, by the way? So if I have here, say, x1 square over w1 plus x2 square over w2 and x3 square over w3 and so on up to xn square over wn, then this is greater than or equal to, it is x1 plus x2 and so on up to xn square over w1 plus w2 plus w3 and so on up to wn. And this is what my T2's lemma means. For all these weights are positive, wi's are positive. So in that case, this is basically 1 square over a plus b plus 2 square over a plus c, and then 3 square over, we have b, and plus 4 square over c, and then 5 square over b plus c, and we have c 6 square over a. So this problem was actually quite simple, but here one of my friend Mayuresh, he told me to make it like this, so I made it this way. Now, if I apply T2's lemma here, then I'll be having here directly, so 1 plus 2 plus 3 and so on up to 6 square here, or if I add them here, I get 3 times a plus b plus c. And now if I open this thing, so 1 to 6, this is going to give me hence the whole square here. So 1 to 6, if I add, then I get 6 into 7 by 2, the whole square, over 1 over 3, because a plus b plus c is 1. So 6, this is 21 square over 3. So 21 square over 3. Yeah. So 21 square over 3 is going to give me 3 square into 7 square over 3. So this and this gets cancelled. So I get 49 into 3. So it's going to be 147. So the answer is going to be 147. Let's go for the next problem. So looking at this problem, we have f of x is equal to x square minus 2 times mod of x. That's another way of writing mod x. And now we want g of x is equal to minimum of f of t and maximum of f of t. That means we need to graph this guy first. So this could be written as mod of x square minus 2 times mod x. And so if f of x, if I take, say I have x square minus 2x, then this is nothing but f of mod x actually. So mod of x square minus 2 times mod of x. So it means we'll draw the graph of x square minus 2x and let's take the reflection. That's it. So I'll be drawing this graph here. Straight line. So I have x square minus 2x. If I plot, then I have zeros are from 0 and 2. So for 0 and 2, I'll just plot the graph. So it would go somewhat like this. And then we'll take the reflection. So while we are taking the reflection, so the x, the negative part of x here, okay, that should be ignored. So if I ignore this much, then we'll take the reflection. So if I take the reflection now, this gives me something like this. Something like this. That's the graph for f of mod x, or you say the actual f of x given. So this part is going to be my -2. So we now have to find the graph of g of x. So let's see the graph of g of x here. So g of x is from -2 to 3 basically. So this is -2, and then here we are going up to 3 here. Now let us see. So I'll use a different coloring. So the first in between -2 to 0 basically. So when my -2 to 0 in -2 to 0 domain, I'll start moving with the variable, and I have to collect the minimum. So for this graph, I have to see what's this point also, because here my function achieves minimum. So if I have x square minus 2x, then I can differentiate here, or it's 2x minus 2 equal to 0. So if x is equal to 1 and -1. So this is -1 and this is 1. So if I start tracing this graph, the minimum graph, so from this graph and this axis line, the minimum we see here is the graph up to here. So once it achieved its minimum, now the minimum value is going to be continued up to here. And then the graph will again break from this domain. So if you run this minimum graph, that means ultimately you will start tracing the graph, and also that line we have to follow. So if you see the minimum is actually achieved, then the graph will continue to achieve its minimum, okay, up to the specified domain. So it will go up to 0. So if this guy received its minimum, that means now it will go like this. Now when I start from 0 to 3, I want the maximum. So when I start tracing out from 0, so I have this x-axis also and this graph. So I want the maximum. So for maximum, I have to start tracing from here, because 0 is max, then negative part. So it will go up to here, and then the maximum part will start from here again. So my graph would go like this. So I'll just graph only the green section. So if I start graphing the green section, so this is my -2, and here I have -1. This is 1, this one is 2, and here one more 3. So from -2 to -1, my graph will go like this, and then from here it's going to be a straight line, and then here it will break, and then this would go on to 2, and then from 2 onwards, it will be again a parabola like this up to 3. These are the points we can write on the graph of equation for g of x. So g of x will look like this. So from -2 to 0, no, -1, and then -1 to 0, and then 0 to 1, then 1 to, no, this is 1 to 2 actually, we could write directly. So 0 to 2 we can write, because 1 is not a critical point even. So 0 to 2, and then 2 to 3. So there will be 4 pieces. So the first piece, this graph, okay, that is when my x is less than -1 here, so this becomes plus. So I have here x squared plus 2x. And between -1 to 0, I have the minimum value. That turns out to be, when I plug in -1, I get -1 again there. And for 0 to 2, I get a complete line, which is 0. And then between 2 to 3, I have the original graph, which is x squared minus 2x. If you see here, then this function is discontinuous at 0. At -1, it is continuous, so no problem. And it's broken at 0. So m is equal to basically 1. So there is only one point of discontinuity. And for differentiability, if you see, then if I differentiate, I get here 2x. So my g dash of x is going to be 2x plus 2 from -2 to -1. And then this is going to be 0 from -1 to 0. And then from 0 again, between 0 to 2, and it is going to be 2x minus 2. So 2x minus 2 from 2 to 3. So now if I plug in here -1, I get this one also 0, but at 0 I cannot, because 0 it's discontinuous. So n is going to be 1 so far. And if I plug in 2, so at 2 also my function is not differentiable, because in the left derivative of 2 is 0 and the right derivative of 2 is 2. So n is going to be 2. So my n plus n is going to be 3. So the final answer is going to be 3. Thank you so much for watching. Stay tuned for the upcoming videos. Let's see you. Bye.